This is quite a tricky question. So here we have two forces acting along a straight line on an object that is initially at rest. One force is constant, so this rightward force is constant. The second force, which is acting towards the left hand side, that is proportional to the velocity of the object. Now we need to figure out which is the correct statement out of all these options. Options A and B talk about the acceleration. So let us try to figure out the acceleration. So acceleration is found by the Newton's second law. So I can write acceleration is equal to the net force divided by the mass of an object. And what is the net force acting on this object? So we have a constant force going towards the right, and we have a left force, which is the varying force. So since both these forces are in opposite directions, so we can subtract them. So we can write the net force will be equal to CF, which is the constant force, minus VF, which is the varying force. We divide that by m. In options A and B, it is saying that the acceleration increases from 0, which means the initial acceleration is 0. We need to check, is that true? So initially t is equal to 0, the object is at rest as it is given. So we can say the varying force is equal to 0. How is that? See, it is clearly mentioned that the second force, which is the varying force, is proportional to the velocity. If the object is not moving initially, so there will be no varying force. So varying force will be 0. So I can write acceleration will be equal to CF minus 0 divided by m. This will be equal to CF upon m, which means the value of acceleration is a non-zero number as it is equal to the constant force divided by m. This will definitely be not equal to 0. Now, in options A and B, it is saying that initial acceleration is 0, which is violating our deduction that acceleration is not 0. Hence, A and B are definitely not the answer. We can discard A and B. All right. In option C and D, it's asking about the velocity. So in option C, it's saying the velocity increases from 0 to a maximum. D is the same, but addition, it says after it becomes a maximum, then it decreases. So we need to identify which of these cases is valid for this particular figure. So let's analyze this. As we earlier saw, the acceleration was equal to CF minus VF divided by m, where CF is a constant force. That magnitude is not going to change. But the varying force, this depends on the velocity. As it is mentioned, the varying force is proportional to the velocity. So as the object speeds up, the value of the varying force will keep on increasing. So just to understand this in a very simplistic manner, let us take some hypothetical values. So let's say if I take CF, the constant force, as 10 newtons, and the varying force will be 0 initially, as we saw that the object was initially at rest. So varying force is directly proportional to the speed of the object. That is why initially the varying force is equal to 0. Now, if we identify the net force, which is the subtraction, we'll get 10 minus 0, which will get us a 10, which means there is an acceleration. Let us imagine that the mass of the block is 1 kilogram. So acceleration will be equal to the net force divided by 1. So acceleration will come out as 10. So we have a positive acceleration. So what does that mean? That the object will start to accelerate towards the right hand side. So the velocity will keep on increasing, which is evident in both C and D. But will the speed keep on increasing forever, or it will decrease somewhere? We need to identify that. So how do we do that? This was the case number one, when the varying force was 0 and the speed of the object was 0. But after some time, of course, the object is accelerating towards the right hand side. So there will be a non-zero varying force. See, varying force is directly proportional to speed. As the object picks up speed, the varying force will become greater than 0. So hypothetically, let's say varying force becomes a 3. Constant force, on the other hand, stays at 10. So what will be the net force? 10 minus 3 becomes 7. Acceleration will also be equal to 7, as we have assumed that mass is equal to 1 kilogram. So analyze, the value of acceleration has decreased from 10 to 7. But in both these cases, the acceleration is a positive quantity, which means the speed is increasing even further. As the speed increases, the varying force also increases further. So let's say after some time, varying force becomes, let's say, an 8, hypothetically. Constant force, on the other hand, will still stay at 10. Net force will be 2 and acceleration will become 2. We keep continuing this process till the time varying force can become equal to the constant force. So let's say varying force becomes equal to 10, constant force is 10. So the net force will be 10 minus 10, which is 0, and hence acceleration will be equal to 0. This is where things get a little interesting. Since acceleration is equal to 0, which means the velocity is not changing. Velocity has become constant now. So let us write the moment acceleration becomes equal to 0, velocity of the object will become constant. Now, since the speed is not changing now, we can say the varying force cannot increase even further because the only parameter on which the varying force depends is the speed. Now, since acceleration has become 0, velocity becomes constant. So, varying force can never go beyond a particular value. In this case, it is 10. So, if we analyze the entire situation, we can say that varying force, the maximum value of varying force is equal to constant force. So, the varying force will keep increasing from 0 until a time it exactly balances out the constant force. In that situation, the net force will be 0, acceleration will become 0, velocity is constant, and after this point, the varying force cannot increase even further. So the entire catch here is the final acceleration becomes 0, velocity becomes a constant. So now if you analyze option D, it says velocity increases from 0 to a maximum. This is fine, but then it says it decreases. This is incorrect because we just saw after some point of time, the acceleration becomes 0 and the velocity at that stage will become a constant, and that's a maximum value. Hence, the answer for this question is option C.